Namaskaram. In this session, we will discuss motion along a curve and its properties. Okay, this is the solution of last homework. Okay, in last class, we have discussed about derivative of a vector valued function. Suppose this is the graph of this function r of t. Then what is r dash of t? This r dash of t is again a vector because r of t is a vector. Okay, so all the vectors are starting from origin. Okay, so suppose this is our r dash of t or at a particular point t. Then what are the two important properties of r dash of t? Okay, and r dash of t has two crucial properties. First one, this r dash of t is a parallel to the tangent at this point. Okay, suppose this is the tangent of at this point of for this curve, then r dash of t is parallel to this tangent. And another important property, the second important property of r dash of t, the direction of r dash of t. The direction of r dash of t is same as the increasing parameter of the curve. In this case, increasing parameter is in this direction. So that direction of r dash of t also in the same direction. So if you move this r dash of t to the end of this vector, then r dash of t is like this. Okay, this is the two important properties of r dash of t. Okay. In this session, we will discuss about motion along a curve and its properties. And its properties means we have to discuss about how to find the velocity, acceleration, and speed of a particle if it is moved through a vector valued function. Okay, let's start. Let us assume that the motion of a particle is described by a vector valued function r of t in which the parameter t denotes time. Okay, for example, this is the function r of t. Okay, and we assume that a particle is moving along this path. Okay, this r of t is called position function or trajectory of the particle. Okay, this function r of t is called that vector valued function r of t is called position function or trajectory of the particle. It is also clear that the direction and speed of the particle may vary when it moves along its trajectory. Okay, so its velocity and speed may differ from different points. Okay, that depends on the trajectory of the particle because that trajectory depends the time t. So our aim is to find the velocity, acceleration, and speed of the particle when its trajectory is not. Okay. So these are the formulas for evaluating velocity, acceleration, speed when the trajectory of a particle is not. That means if r of t is a position function of a particle or trajectory of the particle moving along a curve, here t denotes the time. Okay. Then the instantaneous velocity, acceleration, and speed of a particle at a particular time t are given by these formula. They are familiar with you. Velocity is the derivative of its position function, that is dr by dt, and acceleration is again the derivative of velocity, that's why dv by dt, or it is d square r by dt square, and the speed is given by the modulus of the velocity. Okay. Okay, this table gives the elementary formulas for evaluating velocity and acceleration and speed of a particle when its trajectory is given. Okay, here the trajectory, this is in 2-dimension case, this is in 3-dimension case. Only difference in 3-dimension, we have one more term, that is in terms of coefficient of k is there. So this is the trajectory, r of t equal to x of t I plus y of t j. In the case of 3-dimension, r of t is like x of t I plus y of t j plus z of t k. I j k are the vectors, unit vectors. Okay, then the velocity is the derivative of r of t. So these are the formulas. Here x dash stands for the derivative of x with respect to t. Okay, similarly y dash stands for the derivative of y with respect to t. So these are the formulas for evaluating the velocity. And similarly, these are the formulas for evaluating acceleration. This is a typo. This is not v of t. This is a of t, acceleration of t. So it's a second derivative because acceleration is nothing. It is the derivative of velocity with respect to time. Already velocity is this one. So it's again we have to differentiate with respect to time. So this becomes x double dash. Okay, similarly all other things. And last one is its speed. And how to find the speed? We know that speed is nothing. Speed is the magnitude of velocity because velocity contains two quantities. Okay, suppose this is our velocity vector. Then velocity contains two quantities. One is the direction of the movement and other is the magnitude of the movement. The magnitude is the speed. Okay. So to find the magnitude, we have to take the modulus of velocity of t. Okay. So we know how to find the velocity, no, modulus or norm. It is equal to square root of this term square plus second time square. The modulus of x plus iy. This is equal to square root of x square plus y square. Okay. In the case of three dimension, this becomes square root of x square plus y square plus z square. That is a modulus. And geometrically, what is modulus? Suppose this is a vector, then what is geometrically modulus? Suppose this is our v, then modulus. What about modulus of v? Modulus of v is nothing. It is the length of this vector. Geometrically, it is the length of the vector. Okay. In the case of motion, this length is nothing. It is the speed of the particle at that particular point. Speed of the particle at this point. This vector gives the direction and modulus gives the speed. Okay, so these are the simple formulas for evaluating velocity, acceleration, speed. Okay, consider a problem. A particle moves along a circular path, x equal to 2 cos t, y is equal to 2 sin t. The first question, find the instantaneous velocity and speed of the particle at time t. Next one, sketch the path of the particle, that means trajectory, and show the position and velocity vectors at time t equal to pi by 4 with the velocity vector drawn so that its initial point is at the tip of the position vector. Okay, last part. Show that at each instant the acceleration vector is perpendicular to the velocity vector. Okay. Okay, it is given that this is the path of the particle trajectory. So how to write the trajectory in terms of vector valued functions? Here x of t is 2 cos t and y of t equal to 2 sin t. So the vector form of the path is nothing. It is r of t equal to 2 cos t I plus 2 sin t j. Okay. The first question is we have to find the velocity and speed of the particle at a particular time t. So how to find the velocity? To find velocity, we have to differentiate this r of t with respect to time. So what is dr by dt? To differentiate this with respect to t, the first term become minus 2 sin t and this become 2 cos t. Okay, so velocity vector v of t is equal to minus 2 sin t I plus 2 cos t j. This is corresponding to, if you substitute a particular time, you get the velocity vector of the particular time. Okay, next we have to find speed. How to find speed? We know that speed is equal to nothing. It is the magnitude of the velocity at a particular point. So v of t, modulus of v of t. How to find modulus of v of t? Is square root of this square plus this square. That means whatever the square of the first term, here x of, here the first coordinate is minus 2 sin t. Its square is 4 sin square t plus, and this is 4 cos square t, and 4 is common, you can take outside, so this become, and there is a one more square root, so this become 2 times square root of sin square t plus cos square t, which is 1, so this is equal to 2. So the speed is always 2. Okay, so you say its speed is constant, always 2, whatever with the time, speed is remain same, but velocity is different because it depends one more quantity, the direction. Okay, so but its speed is throughout same. Okay, next we have to sketch the path of the particle. Okay, path of the particle is nothing, r of t equal to 2 cos t I plus 2 sin t j. So geometrically, what about this one? Actually, this is our x of t and this is our y of t. And it's clear that x and y satisfy a simple equation. What is a simple equation? Here x square plus y square. What about x square plus y square? It is nothing, it is 4. Isn't it? This is 4 cos square t plus 4 sin square t. So you can take 4 outside. So this become 4 times 1, that is 4. So x square plus y square equal to 4. So it is clear that the path is circular. The path is circular. And there is a natural question, which is the orientation of this path. Okay. To trace the orientation, you simply substitute some values for t. When t equal to 0, what happened? When t equal to 0, x is when t equal to 0, what about x value and what about y value? When t equal to 0, x value is 2. Okay. And what about y value? Y value is 0. So when t equal to 0, this is the point 2 0. And suppose t is gradually increasing, what happened? This direction or this direction? For example, next symbol t is, suppose you substitute t equal to pi by 2. Suppose time equal to pi by 2. And time equal to pi by 2, what about x value? X value equal to cos pi by 2 0. So this is 0. And its corresponding y value is sin pi by 2 is 1. So it is 2. So this is the point. This is the point 0 2. So it is clear that if t is gradually increasing, here actually t equal to 0, this is and correspond t equal to pi by 2. If t is increasing from 0 to pi by 2, the curve tracing in this order. So this is the increasing parameter direction. So this is the direction of the curve. So this is the orientation of the curve. So this is the orientation of the trajectory of our particle. Okay. So first part is over. Next we have to find the position and velocity vectors at time t equal to pi by 4. Already we evaluated position vector and velocity vector in terms of t. So we have to find the position and velocity at particular time t equal to pi by 4. So we have to simply calculate r of pi by 4 and v of pi by 4. They are the position and velocity of the particle at a particular time t equal to pi by 4. T equal to pi by 4 is somewhere here. Okay. So what about the position? The r of pi by 4 is nothing. 2 cos pi by 4. 2 cos pi by 4 I plus 2 sin pi by 4 I. So 2 sin pi by 4 j. So what about this quantity? We know that cos pi by 4 and sin pi by 4 both are 1 by root 2. So this become root 2 I plus root 2 j. So this become root 2 I plus root 2 j. Okay. Similarly, we have to find velocity at pi by 4. You simply substitute pi by 4 in this formula. So this become minus 2 sin pi by 4 I plus 2 cos pi by 4 j. And similar to this case, this is again root 2. So minus root 2 I and plus this is again 1 by root 2. So root 2 j. So this is the position and this is the velocity at time t equal to pi by 4. Okay, so what about r of pi by 4? R of pi by 4. In Cartesian system, this is root 2, root 2. So root 2 is somewhere here. This is the point root 2, root 2. So this is the vector r of pi by 4, isn't it? This is the vector r of pi by 4. Okay, so this point is root 2, root 2. Clear that it is clear that this point belongs to this circle. Because x square plus y square equal to 4. Here x square is 2, y square is also 2. So their sum is 4. So it is clear that this point belongs to this circle. Okay, at this point. So this is the vector r of pi by 4. Next we have to plot the velocity vector at the end of this vector. Okay, at the tip of this vector. So first we have to draw this vector and you shift it to this point. Okay, how to plot this vector? Okay, the Cartesian form of this point is nothing, it is minus root 2 plus root 2. Then how to plot this vector? First of all, we have to find this point. The minus root 2 means x value is negative, so somewhere here, and y value is positive, it is root 2 somewhere here. So this point is on the circle because here is this is our x value, this is our y value. It is clear that x square plus y square equal to 4. So this point is belongs to the circle. Okay, and its position is somewhere here. X is negative and y is positive. So this is the point. So the vector is like this. Vectors are always starting from origin, and this is our endpoint. Okay, so our vector is like this. Okay, this is not perfect. So yes. So anyway, this is our vector starting from origin, and this point is nothing in Cartesian form. This point is minus root 2 plus root 2. Okay, this is our velocity vector v of uh, v of v of pi by 4. Okay, and the question is we have to shift. We have to plot this velocity vector at the end of this position vector. So our this is the almost like this. We have to shift this vector parallelly. That's all. We have to shift this vector parallelly at this point. Okay. So ultimately, this is our trajectory of the particle. This is the position vector at pi by 4, and this is actually velocity vector at pi by 4. But if you plot this at this point, then we get like this. So this is the direction of the velocity at this particular point. Okay. And the modulus of this vector is nothing. It is a speed. We know that the speed is 2. Okay. These are the things. Okay, I will show you the correct picture of this second part. This is the exact figure. This is the circular path is the trajectory. In this anti-clockwise direction is the orient of our curve. And this vector is the r of t at pi by 4, that is root 2 I plus root 2 j. And this is our velocity vector. Actually, the velocity vector is not this. Velocity vector is like this, because the vector is nothing. It is minus root 2i plus root 2j. Vectors are always starting from origin. Okay, but the problem is we have to plot this vector at this point. That's why we shifted. Okay, that's all. Ultimately, this is the final shape of our figure. Okay. Okay, in third part, we have to show that the acceleration and velocity are perpendicular. How to show that two vectors are perpendicular? The easy method is by take the dot product. If v1 and v2 are two vectors, they are perpendicular if and only if their dot product their dot product is 0. Okay. So your one vector is velocity. That is already we have already we find the velocity vector. Next we have to find the acceleration component. What is acceleration? Acceleration is nothing. It is the derivative of velocity. So you simply differentiate this velocity vector. By differentiating this velocity, we get minus 2 cos ti, minus 2 cos ti, and minus 2, again the derivative of cos is minus, so minus 2 sin t j. So this is the acceleration vector, and we have to show that they are perpendicular. To show that, we have to show that velocity dot acceleration is equal to 0. And how to compute the dot product? You simply take the product of I component plus product of j component. That is very trivial. So you can easily verify that their dot product is 0. Okay, so these two vectors are always perpendicular. Whatever be the time, acceleration and velocity are always perpendicular. Okay, that's it. Second problem. A particle moves through three-dimensional space in such a way that its velocity v of t is given, that is I plus tj plus t square k. Find the coordinates of the particle at time t equal to 1. Given that particle is at the point minus 1, 2, 4 at time t equal to 0. It is given that the particle is at this position at time t equal to 0. Okay. Also given that the velocity vector corresponding to every time. We have to find the position of the particle. Okay. Okay. We know that the velocity vector v of t is obtained by differentiating our position vector r of t. Okay. So in this case, position vector is given. So we have to, sorry, in this case, velocity is given. So we have to find the position. So what is the converse process? Yes, integration. By integrating velocity, we get the position. Okay, that means by integrating velocity with respect to time, we get the position vector. Okay, then but integration does not give exact position. Why? Yes, because integration involves a constant of integration. So we have to remove this constant of integration. To remove this constant of integration, we have to use this initial condition, because it is given that initially the position of the particle at this point. Using this condition, we can easily evaluate the C. Okay, so that is the idea of this idea of this problem. So the position vector r of t is equal to integral velocity, that is equal to integral velocity is given I plus tj plus t square k. And what about the integral of I? That is nothing t. So ti plus this become t square by 2, t square by 2 j, and this become t cube by 3, t cube by 3 k plus a constant of integration. Okay, so this is so our position now. Our position vector is like this. This plus a vector plus a constant of integration. We have to find this constant of integration. Okay, using this condition. So this condition gives the position of the particle at t equal to 0. Okay. So what is the position vector? So what is the position vector at t equal to 0? Yes, it is. We can denote it as r of 0. What is this? Yes, this is nothing minus 1 I plus 2j plus 4k. So this is the position vector at time t equal to 0. Okay, so this is the general position vector. So we can substitute t equal to 0. Next we have to substitute t equal to 0 on this equation and equate with this given condition. Okay, when t equal to 0, what about our position vector? This term becomes 0, 0 I plus 0j plus 0k plus c. Okay, already r of 0 is known. So what happened? By comparing these two, we get c equal to minus I plus 2j plus 4k. You got the idea? So r of t equal to this one, we substitute t equal to 0 on this equation, we get r of 0 equal to c. Already r of 0 is given like this. So we can equate these two. Okay, so so this gives c equal to like this. Next we have to substitute c on this equation, that gives r of t. So r of t become ti plus t square by 2j plus t cube by 3k plus c. What is c? C is minus I plus 2j plus 4k. Next we have to compare the terms containing I and j and k. So this become t minus 1 I plus t square by 2 plus 2 times j plus t cube by 3 plus 4 times k. So this is the position vector of this particle. Okay, ultimately we have to find the coordinates of the particle at time t equal to 1. So first we are going to find the position vector of the particle at time t equal to 1. So what is r of 1? So r of 1 gives the position vector at time t equal to 1. You simply substitute t equal to 1. When t equal to 1, this become 0, 0 I plus this term become 5 by 2. So this become 5 by 2 j, and when t equal to 1, this become 1 by 3 plus 4, that become 13 by 3. 13 by 3 k. So this is the position vector of the particle at time t equal to 1. We have to find the coordinates. That is very easy. So what is the coordinate? The coordinate is nothing. It is 0, comma 5 by 2, comma 13 by 3. Okay. So this is the coordinate of the particle at time t equal to 1. That's it. Yes, the coordinate is 0, 5 by 2, 13 by 3. That's it. Okay, clear. Okay, these are the homeworks for this session. We have 3 problems. Thank you.